Let's consider what happens when we're using the 1 to 2 rule, or 2 to 1 rule, and how we can label these boxes. So let's start with 1 dot. Here we've got the 1 dot. This is the plus 1 dot. I'm going to put that 1 dot in the very first box. And since I started with 1 dot and I have 1 dot in this first box, I'm going to label that box 1. For for 2 dots, let's just add 1 more dot to the 1 we already had. So we're going to put this new dot here in the 1's place, but we're using the 1 to 2 rule, or 2 to 1 rule. We're going to explode these 2 dots into the box to the left, which doesn't have a label yet. But let's see, we've got 0 dots left in the 1's place and 1 dot in the box to the left, and we had 2 dots total. So let's label this box 2. So now we've got the 1 box and the 2 box labeled. And we can see that the 1 to 2 code for 1 dot is 1. And if we think of these as leading, or zeros that come before, we can write 1 as 0, 0, 0, 1. And we can write 2 as 0, 0, 1, 0. Or we can just write 1, 0 for 2. Groovy? If we add another dot to the 2 dots we just had, then we've got 3 dots total. And let's stick this new dot in the 1's place, and there we can see the representation of 3 dots is 1 dot in the 2's place, 1 dot in the 1's place, and if we want to think of this as having zeros in front, we can write 3 dots equals 0, 0, 1, 1, or just 1, 1. And what we're going to start to do is put a base. So I'm going to put a little 2 below the level of the number to indicate base 2. Or, in other words, the 1 to 2 rule. All right. Well, let's start with 3 dots. So let's start with a 1 and a 2 and add another dot. So we've got 4 dots in total. This new dot goes in the 1's place. And now we've got 2 dots in the 1's place and 1 dot in the 2's place. But we can't have 2 dots in any box. So these 2 dots in the 1's place will collapse into a new dot in the 2's place, and we've got 0 left over in the 1's place. And now, again, we can't leave 2 dots in a single box using this rule. So we're going to collapse these 2 dots to the left. And now we see we've got 0 dots in the 1's and 0 dots in the 2's. We've got 1 dot in the place to the left, which we have not yet labeled. But this time we started with 4 dots And we've got zeros in the ones and twos places, so it makes sense to label this next box the fours box. And in fact, we can write that 4 dots is the same as 1, 0, 0, base 2, and that's exactly the same as 0, 1, 0, 0, base 2. But the number of zeros out front doesn't matter. 0, 0, 0, 1, 0, 0, base 2. And just for comparison's sake, let's think of a number in base 10. What about the number 6? So I've got the number 6. Is 6 the same as 0, 6? And is 6 also the same as 0, 0, 0, 6? Are those the same? And yeah, of course they are. We can put zeros on the left side of any number and not change it. And I'm going to put a little 10 to remind myself that this is base 10. Anytime it's unclear what base I'm working in, I need to put a little number to the lower right. Okay, so that's what I mean by adding boxes or adding zeros to the left. We can add as many as we want. Well, let's take the 4 dots and add one more. So now we've got 5 dots. Let's see, 5 dots. I've got 4 dots here, and I'm adding one more. And I'm moving that one into the ones place. I always start by moving it into the ones place. And there we have it. The binary or base 2 representation for 5 dots is 1, because there's a 1 in the fours place, 0, because there's a 0 in the twos place, and 1, because there's a 1 in the ones place, and this is all base 2. Well, let's continue. Let's add another dot to the 5 dots that we had. So we've got 1, 0, 1, and we're adding another. We always add to the ones place. So this time we're ending up with 2 dots in the ones place, which we cannot have. So these 2 dots will explode to the left and give us 1 dot in the twos place. We still have a dot in the fours place, and we no longer have any dots in the ones place. So that 6 dots is equivalent to 1, 1, 0, 1, 1, 0, base 2. Or 1 dot in the fours place, 1 dot in the twos place, 0 dots in the ones place. We're just going to do this twice more so that we get sort of the hang of it. So if I add another dot to the 6 that we had before, I add it to the ones place, and I find that this is okay. I only have 1 dot in each place. So I can see that 7 dots is equivalent to 1 dot in the fours, 1 dot in the twos, 1 dot in the ones. And the base is 2 because we're using the 1 to 2 rule. We're going to, on the next step, we're going to start with 7 dots and add another. So we're going to start with 1, 1, 1. Okay, we've got 1, 1, 1, and we're adding another. And like we've said about a million times already, we cannot leave 2 dots in a single box if we're using the 1 to 2 rule. So these 2 dots have to collapse into 1 dot. To the left, now we've got 0 dots left in the 1's place, but we have 2 dots in the 2's place, which we're not allowed to have. So let's take these 2 dots and expand them to the left. Well, now that means we've got 0 dots in the 2's place. We had 0 dots still in the 1's place. But now, this new dot that we just added to the 4's place joins the 1 dot we already had there. So we've got 2 dots in the 4's place, which we cannot leave. So let's take those 2 dots and explode them left. And let's see if we can come up with a label that makes sense for this box that is to the left. So we've got 0 dots in the 1's place, 0 dots in the 2's place, 0 dots in the 4's place, 1 dot in the place to the left, and we had 8 dots to begin with. So it makes sense to label this new box 8. So that 8 dots is equivalent to 1 dot in the 8's place, 0 dots in the 4's, 0 in the 2's, 0 in the 1's, and base 2. The number of boxes does not have to stop at 4. We can have more boxes to the left. So one of the questions, or two of the questions that will follow, are how will you label the box to the left of the 8 box and the box to the left of that new box? And before we leave base 2, let's look at something really lovely. Let's use rules of exponents to rewrite these numbers with a 2 as the base. So 2, 2, 2, 2. What exponent can I raise 2 to get 8? So 2 times itself, how many times is 8? Good. 2 times 2 times 2 is 8. And 2 times itself, how many times is 4? Good. 2 times 2 is 4, so 2 squared is 4. 2 to the 1 power is 2. And any number to the 0 power is 1, except 0 to the 0, which is not defined. So this, now I can write the 1's place as 2 to the 0's place, the 2's place as 2 to the 1's place, the 4's place as 2 squares place, the 8's place as 2 cubes place, and now it's easier to see going forward. And let's just connect this really quickly with what we know of base 10. Okay, so we've got, I can write this as 10 to the 0, that is 1. 10 to the 1 is 10. 10 to the second is 100. 10 to the third is 1,000. So it works exactly the same way.